So the chapter 2 for the brushless DC motor mainly focus on the configuration for the control method, how we're going to control that. And then this mainly about the current mode control. Current mode control is one of the typical methods to control the motor because current and torque are proportional to each other in most of cases for all the motor. So that means all the motor we tend to use current mode control, which is the torque control. We firstly show you some simple circuitry, how to do that. You may not have too much concept in the power electronic circuitry, but here I show you some basic principle, how to do that. And then we also try to look into the torque calculation under the control method. And then we also try to work out how to work out the torque ripple. So a few target questions will be, do you think the control of brushless DC motor will be the same as the brushless motor? Do you think they are exactly the same control method?
Yes.
Only up to the constant torque control. Beyond the constant torque control, when we go to the beyond the base frequency, overdrive, we need to use another control method because one can use field weakening, one cannot. Of course, for those PM motor, we cannot use field weakening. Only separate excited DC motor, we can use field weakening. And then if both of them are PM motor, then the control method will be quite similar. Then, how are we going to control the motor current? Before in DC motor, we can use voltage to control it, DC voltage, but now we don't have DC voltage. We do have DC voltage, right? But the DC link voltage applied to the inverter, we can increase the voltage probably. Then, of course, but in here, since we got the inverter, no point for us to increase the motor voltage by changing the DC link. Because when you change the DC link, you see we got inverter here. And then we connect to the brushless DC, right, motor. And then this DC voltage, in theory, you can using a DC to DC converter to change to vary this output to do that. But since we got an inverter, why don't we just change the duty ratio here to change the voltage rather than to use two to do that? Of course, a conventional DC motor, we just using a conventional DC motor, then we can just using DC to DC. That should be good enough to do that. But since we need to have an inverter, so we try to merge all of this technology into the inverter to have one inverter to control the motor. That would be much better. For circuit point of view, we need to polish our inverter to do two jobs. And then, of course, position sensor, we already mentioned, we do need to have a position sensor to sense the position. And next is to ask you about the market share. How do you see the market share for brushless DC compared to conventional DC? Which one have a high market share? Brushless DC, the one we are teaching now, compared to conventional brushless DC motor. Which one have higher market share?
This one more.
Huh?
For the brushless, it should be more. Yeah, this one more.
Yes, and actually getting more and more. I think it's now, roughly very much the same, but now we're getting more into the brushless DC. I think probably in a few more years, brushless DC will replace most of the conventional motor. Conventional motor has been in the market for quite some time because they're really mature. Many products still using the old design. They are reluctant to change the old design to brushless DC. But since we got new product, and many countries, including mainland China, producing many brushless DC motor controls, really cheap, just a few dollars, then getting replacement for everything. So we're now getting really high market share now. The efficiency, do you think the efficiency of motor will be affected by the controller, by the driver? Now, we know the motor efficiency, motor itself, what efficiency it is, mainly due to the RA, the armature resistance, right, or winding resistance. But when we're using this motor driver, do you think the efficiency will be lower or higher or unchanged or even better? What do you think? Efficiency could be increased, right? Okay. Sheldon, what do you think?
Yeah, I also think we use the control method properly, the efficiency will be.
That's what other people think, yeah. But the motor itself is the motor. The motor itself won't be changed. But however, you need to see about what efficiency will be modified. One thing will be we are now using high frequency waveform to drive the motor. When we use high frequency waveform rather than DC current waveform, the loss inside motor winding could be different. The core loss could be different. But how much different, we're not quite sure. So in theory, then the motor itself is still the motor. But when we use brushless DC, high frequency may have some effect to the overall efficiency. So the high voltage DC motor, we can use the variable voltage. In here, we can also using variable voltage to drive the brushless DC motor. So do you think if we apply for high voltage to drive the motor, then can we maintain the efficiency? What I meant was if this DC brushless motor is 220 volt, our driver here will be, for instance, we are using say 48 volt. So therefore we use duty ratio to control that. So we can use variable duty ratio to reduce 48 volt to suitable more 20 volt to drive the brushless DC. So now the high voltage and low voltage will affect overall performance, the efficiency. Vertically, it won't affect overall efficiency. But however, a little point we haven't done in this lecture will be the core loss really change the overall performance. Because high voltage usually means higher core losses. But of course, we don't cover in such a way. Anyway, so this chapter we're going to cover the torque control, how we're going to do that. And then we also try to examine about the various control method. And then we also have some tutorial to go through them. So firstly, what's the time? 43. So the commutation, internally with this motor, we do need to have a built-in commutation. The commutation actually will be inside the brushless DC motor driver system. The motor itself cannot run by itself because brushless DC motor must using power electronics to do that. So in theory, we need a position sensor. And then the position sensor usually can also help us to determine the motor speed. So all these components add together become our brushless DC motor. Of course, we do have a controller to control overall speed. So that means the motor driver we try to introduce here will be firstly show you how the motor driver look like. How do we going to control the motor current and the motor speed too? But the modeling for this will be really much the same as the conventional DC motor. One thing you can see that we're now going to have torque control. All the motor we go for torque control. Once we have torque control, we can therefore control the motor acceleration and the deceleration. We can therefore control the motor speed. So torque control is more basic. Usually appear in the motor drive with inner speed loop to control them. So to do this one, then we know that we firstly need to control the motor current. So the motor torque and current are proportional to each other because the torque constant will be unchanged anyway because we are using fixed permanent magnet. So most of control method for torque control are mainly is so-called the current mode control. We control the current. So how to control the current? So next section, we're going to show you how to implement the current mode control in this kind of the brushless DC motor. So we go through it. So on Thursday, any question up to this point? Okay. Then we continue then and soon on Thursday.